this out. CBD of Atlanta, Georgia, challenged us to find a way to keep bubbles from popping, and a friend suggested this. See how the bubbles are floating right here in the tank? Do you know why?
The bubbles are floating on a layer of carbon dioxide. We create the carbon dioxide by mixing an acid, which is vinegar, and baking soda.
Here's what happens when I blow bubbles into a tank with just air in it, no carbon dioxide. See, the bubbles don't float.
Here's how you can try this in your kitchen at home. Okay. First, pour some baking soda into a clear container.
Okay. I'll help you. Okay. Ready? Yes. Sprinkle it on.
I'm going to pour 2 cups into the container. You don't have to use a container as large as this one we're using. This will work in a small one as well. Just use less baking soda.
Now we're going to pour vinegar into the container. For this large container, we're going to use 8 cups. Ready?
Yep.
Look how much it's fizzing.
Cool. It's neat.
And all the little tiny bubbles.
Yeah, it's like soapy foam.
Do you see the bubbles that the vinegar and baking soda are making? They're actually making carbon dioxide. Look at that.
I know, that's so cool. Now, blow some bubbles into the tank and watch how they float on the carbon dioxide. Okay, ready?
Ready?
That's so neat.
It's so cool. They're just like suspended in the air.
Wow. Here, I'm going to blow a few more.
By blowing bubbles into a container with carbon dioxide in it, you're able to tell where the carbon dioxide and air meet. So if the bubbles are floating right here, like these are, then the air is on top, right here, and the carbon dioxide is down here.
The carbon dioxide stays at the bottom of the tank because it's more dense than the air in the tank. The bubbles float on top of the carbon dioxide because they have air in it, and the air is less dense than carbon dioxide.
Cool. This will better explain density. I have 2 balloons right here. One is blown up with air, and one is blown up with carbon dioxide that I made by mixing vinegar and baking soda together. Here, Rach, can you hold these for a second?
Sure.
Thanks. Ready? This is vinegar, and this is baking soda.
Ah! Oh my gosh, that's so cool.
It's gonna explode.
Cool.
Both of these balloons are the same size, which means that the gas inside of them is taking up the same amount of space. So this one is carbon dioxide, and this one is filled with air.
But when weighing both balloons, you can see that...
Ready?
Yep.
Whoa.
That when weighing them, the one with carbon dioxide is heavier than the one with air in it, which means that carbon dioxide is more dense than the one with air in it.
Look at it's much.
Wow, that's a big difference. Look at it. It's like.
I know, you never guessed that the air inside, or the carbon dioxide inside a balloon would be heavier than one.
Yeah.
If you still don't understand density, don't worry. There's a lot of people who can explain it to you. You can talk to a teacher, go to your local library, visit a science museum, or talk to your parents. So let's blow some more bubbles in the tank. Ready? I'll stop. I'll wait till they're dripping.
Yeah.
Okay, ready? Okay. Oh, look at all of them. They're so tiny.
Let's have a little more.
Oops. None of mine went in the tank.
Whoa, look at that big one. We know that bubbles floated well on carbon dioxide, which we made by mixing baking soda and vinegar. But there are other ways of making carbon dioxide.
Do you remember when Garrett and Caroline launched rockets by mixing baking soda and lemon juice together? Well, later on in the show, Rachel and I are going to try to float bubbles on top of lemon juice and baking soda.
We're going to test other mixtures.
We think lemon juice works, right?
Yeah,
because Garrett and Caroline launched rockets off it, so it must be pretty powerful. So let's use that.
How about cola? Do you think that would work?
I think cola will work because there's lots of bubbles in it, and the bubbles are probably filled with carbon dioxide, so that probably will work. What about apple juice? Do you think apple juice will work?
Actually, yeah, because a lot of fruits have acid in them, so I think apple juice would work, but I don't think it would be as strong as lemon juice.
Okay,
we can
so
try it.
why don't we try lemon juice, apple juice, cola, and...
Do you want to stick with vinegar?
Okay, yeah, that's a good idea.
Okay.
So these 4.
Okay.
All right. So since we have an equal amount of baking soda in each container, to test it out, we're going to have to put an equal amount of liquid in each container as well. All right, so
Start with this. So we're starting with lemon juice.
Okay.
So,
Okay.
so here.
We're going to use 2 tablespoons and put it in the container.
Mm-hmm.
Here, we should probably
good
pour it
idea.
over the glass.
That's good.
Okay, 1. Oh, look at it fizzing. And 2. There's a few. Okay, there's some little ones.
There, it works. It
Keep
doesn't
going for a
stay as
second.
long, it pops.
As the vinegar, yeah. But I think it floated well.
Yeah, so
I'm
it
not
works,
sure.
except it doesn't have much carbon dioxide.
Yeah.
Okay,
Now
let's
which
try
one do you
apple
want?
juice.
Sure. Okay.
Cool,
So
I
get
can't
ready with
see
that.
this
Do
one.
you want to pour it in this time to
Sure.
the tablespoon? Oops.
Okay, let's make sure we pour it over the cup.
Yeah.
Okay. Oh, this is a big opening, so I don't want to...
I'll move to you.
Okay, that's good.
1.
It's not
It
making
didn't
much
make a lot of
foam.
2.
Whoa.
It didn't make a lot. I'm not even
let's
sure if it's
try
going to
it.
float.
Okay. Oh,
Okay.
good job.
Thanks.
Yeah.
Yeah,
see, it goes
they're
right
not
in.
floating.
So this one doesn't work, so we'll just put it
Okay.
over here then.
Do you want
Okay,
to try?
let's try cola. I'm excited about this one. I want to see how.
I know, I'm excited too. I want to see if it works.
Do you want to hold it and I'll pour it?
Sure.
Sure, I don't want
Okay.
to foam.
'Cause that's funny to think things that you drink have a lot of acid in it.
Yeah.
It doesn't sound really appetizing
I
once
know.
you know.
That's good for you.
Okay. A little. Okay.
Okay.
Ready?
Ooh, that's cool.
It works. Not. It doesn't
It
have
looks
that
like
big of a
like when you
reaction,
pour Coke into cup, like just
but- Yeah,
how it
it
foams
just
a little.
fizzes. But I think the baking soda adds more bubbles. Yeah,
Okay,
you can definitely see
so
the carbon dioxide.
How about you
bubbles.
blow? I think you're a little better at doing that for me.
Bubbles.
Because it looked like when one would see they fell
Yeah.
right in the Coke.
I think the
On
cola
top
is
of
making carbon dioxide, but not enough.
I thought it was
have
going
the
to work at
bubbles float
first because
on
it
a layer.
foamed,
Yeah,
and
it
I was
did
like, oh,
fizz.
cool, and then all of a sudden it went down like it does like in cup. Like
But I think also the bigger the fizz of the liquid, I think that means it has more carbon dioxide.
yeah, I think you're right too
Because the lemon
yeah.
juice had it almost had like an
and
explosion
it worked,
inside the
except
cup.
it wasn't the bubble didn't float as high.
Okay, so what do you think between apple juice and cola?
I think they're kind of the same.
So
I think
vinegar.
vinegar is gonna win. Ooh, this is strong. It smells strong.
I know, you can smell this from miles away. Okay, ready?
Okay, well,
Yeah, that has a
look
lot
at
of
how
foam
much
already.
foam there is. That was only like 1 tablespoon.
And all of the liquids foam like have their own foaming way.
yeah. Oh, catch that
There,
one.
that's a lot.
Look at that. Oh.
There.
Look at those. That's
wow,
so cool.
that floats really well.
That's awesome. So I think vinegar is the winner. Here are all the liquids we tested lined up. Vinegar and baking soda made the most carbon dioxide, then lemon juice, and then apple juice and cola made the least carbon dioxide.
Alini and Matt tested these liquids earlier and learned that lemon juice was a strong acid and that cola was a weaker acid. We figured that the liquid that made more carbon dioxide, lemon juice, is a stronger acid than the one that made less, cola.
Experiment with bubbles and carbon dioxide at home. If you come up with any interesting discoveries, send it to Zoom.